So I'm starting. Please give me a second. I'm coming in. Okay, so two particles P and Q are shot vertically up. Particle P is first up with a velocity 40 meters per second. After 4 seconds, particle Q is also shot up. Find A, where the two particles meet. Then where the two particles meet, if at the point of meeting, P has velocity of 15 meters per second. B, the velocity with which Q is shot, taking gravity to acceleration due to gravity to be 10 meters per second squared. This was the weekend or is the weekend challenge. You see, two particles are being shot vertically upwards. If I have this and this, okay, and I'm shooting them vertically upwards or projecting them upwardly. If I throw both particles at the same time, there is no way they are going to cross because they are shot at the same time with the same velocity or force. They will travel parallel to one another. They will never cross. They can only cross when one is shot earlier than the other. So if I delay the throw of one of them, throw this one first and delay this will get to a maximum height. Then when it is coming, because the projection or the throw of this is delayed, when it is coming, it can cross the other one. Please, are you with me?
Yes, please.
So that is the reason why. That's the reason why particle Q was delayed. Because if you don't delay it, they cannot cross. What it means is that because particle Q is thrown first, it will reach a maximum height and then return. And during the return part, would meet this one at a certain point. So P would have to travel to a maximum height, and then when it is returning, then it can cross Q. That is the whole argument. Okay. Now, let me divide the board into parts. Please, I'm coming in. I want to change my marker. So, a second. Okay, so let me bring the screen somewhere here. So let's assume that both particles start from the ground. This is the ground level. Then P is thrown vertically upwards. This is P. This is particle P. It is thrown with an initial velocity of 40 meters per second. Okay. Now, P would go up, get to a maximum height, and upon its return, 4 seconds later, Q is also projected. So Q is projected here. Okay, we don't know the initial velocity U, not known. But let's assume that both particles would cross at a vertical height x. So from the ground to where they would cross, let's say that the distance, okay, there, or the vertical height is x from the ground. Because for them to cross, Q would have to go up, and when it is returning from the maximum height, that is when it will cross Q. So while this has gotten to its maximum height and it is coming, it will then cross Q. Is that okay? So let's assume that the point where the two particles cross is x distance from the ground. So this height is what we are calling as x. They will cross at a distance x. Please, class, are we okay?
Yes, please.
Good. Now, you see, you were told that if calculate where they will cross, if at the point, find the where the two particles meet, if at the point of meeting, P has a velocity of 15 meters per second. If at the point of meeting, this P has a velocity of 15 meters per second. Okay, Q is being shot up with an unknown initial velocity. But what they are saying is that we have to calculate the point where they will meet if at the point of meeting, P has a velocity of 15 meters per second. So this is where they are meeting. And for P, we are assuming that at the point of meeting, it has this velocity. Okay. Now, some of you, based on what you submitted to me, you took this value of P as a final velocity. And so you used V squared is equal to U squared, because it's going up, minus 2JH to find the height where they will meet, which fortunately gave you the answer. But to some extent, the method is wrong. But you had it right for some reason, which I'll talk about. So if you are using this, you are assuming that the point where they cross is the final velocity of P. So 15 squared is equal to the initial velocity of P, 40 squared, minus 2JH, and J is 10. So times 10 times H. You put this together and you had 20H is equal to 40 squared minus 15 squared. Therefore, H is equal to 40 plus 15 times 40 minus 15, all divided by 20. Okay. And so, finally, your H value, calculate H value for me. This is 55 times 25, right? Divided by 20. Hello.
Hi.
Good. There was an intermittent break. Okay, so calculate that for me.
58.75.
Yeah, so H is equal to 68.75 meters. Yeah, this is the answer. But you see, the approach is wrong. But because you got it right, because when the body is going up, whatever it has is equal to what when it is coming down. This is the reason why your answer is wrong. So if you think, if this is it, now let's determine the time where the two particles, okay, the time for P to cross Q. Let's find the time for the particle P to cross Q. Okay, so if V is the final velocity 15, U is the initial velocity 40, and P would rise to a height 68.75 to cross Q. Let's find the time at that point or at this height. Using this, let's use this equation. If you use equation 1, V is equal to U minus JT. Class, are you there? Are you
Yes.
there?
Yes,
Yes,
Good.
yes, please.
So what is V? V is 15. What is U? U is 40. J is 10. So T. Then we have 10T is equal to 40 minus 15. And 40 minus 15 is 25. So 10T will have T giving us 2.5 seconds. Are we okay? What
Yes.
what you are saying is that P would cross Q at a time of 2.5 seconds. Okay, if you are saying they will cross at this height, which is true, then you are saying that the time for which P would cross Q would be 2.5. Meanwhile, the question is saying that P is thrown, and after 4 seconds of the journey of P, okay, Q is thrown. So if this is 2.5, then it doesn't match the information given from the question. Please, class, are you okay?
He said, yeah.
Hello?
He said, yeah, please. I'm trying to say that what we've done, it will be like 2.5 is the total time taken for P to meet Q.
Exactly. Exactly.
Okay.
The time for
Right.
which P would cross Q is this time. That is what it means. Okay. So let's look at how the whole thing, okay, has to be solved. As I said,
Mr. Dear.
hello.
So please give me that those that did this one, they are wrong, or in examination they would have been marked down.
You see, the height is correct, but this time is wrong. And the use of 15 meters per second as a final velocity V for P is also wrong. But because when you are going up and when you are coming down, the body is accelerated by the same gravity, but one will be accelerating when it is coming down and it will be decelerating when it is going up, but the same magnitude. That is why coincidentally this answer is correct. Are you okay?
Yes,
So
please.
let's look at how to solve the question. Now, as I said earlier, for them to cross, P would have to be thrown first, get to a maximum height. When it is returning, then because Q, the throw of Q is delayed, it can cross it. Are we okay? So what I want us to find first is the maximum height reached by P. So considering P, particle P, the maximum height that can be reached by it is equal to U squared over 2G. So this is equal to 40 squared on 2 times 10. And that will give us 80 meters. Are we fine?
Yes, please.
Then let's also calculate for the time taken by P to reach the maximum height or the highest point. So T max, which is equal to U over G. And this will give us 40 divided by 20, which is equal to two
It's 10, Mr. J.
pardon?
It's 10.
Sorry, 10. So 4 seconds. Okay, what this means is that for P to be thrown and get to the maximum height, it would have to travel this whole distance, which is equal to 80 meters, and the time taken to reach the maximum height would be equal to 4 seconds. So after 4 seconds, okay, for Q is thrown, meaning that's at the point where Q is thrown, P is already here. Class, are we okay?
Yes, please.
As at the point where Q is thrown, P is already at the maximum height, because the question says, and after 4 seconds, Q is thrown vertically upwards. If you have any question here, ask before I continue. Eresi.
So, Mr. Edia, so like you are trying to say that when the Q particle was thrown, the P particle was free falling.
Yes, because it is already at the maximum height. And the question says, and after 4 seconds, Q is thrown. So by the time Q is thrown, the body P is already at the maximum height and it is about to fall freely. Eresi, are you okay?
Yes, please.
Good.
Thank you very much.
Okay. Now we are assuming that the two particles cross at this height x. So let's determine either the time or the distance taken for P to move from the maximum height and come to this point where they will cross. Let's find the time and the distance. Can you do that for me? Class, can you do that for me?
Yes, please.
Quickly try, give it a try. I think two minutes will do, so let's hurry up. So after 4 seconds, P is free falling. And in free fall, initial velocity is 0. We are calculating for this height, and then the time t to this height. Are we through? Are we there?
Yes, please.
What did we get for that? Yes, Amma.
Sir,
What did you
please,
get?
for the height, I got 11.25 meters.
So h is equal to 11.25 meters. Amma, how did you do it?
I used the third equation of motion.
Which is
V squared
v
is
squared
equal to
u squared
U squared plus 2GH.
And what is your v?
15.
So that you see, then the question is saying if at the point of crossing, the final velocity, so they are crossing here. So at this point, both P and Q are here. P is coming down, Q is going up. Okay, at this line, both P and Q are crossing. P is coming down, Q is going up. And the question says that at this point, the final velocity, the velocity of P is 15. So 15 squared is equal to, now P is free falling. So U is 0 plus 2 times 10 times H. Okay, therefore H becomes 15 squared divided by 20, which gave her 11.25 meters. So it means that then Q, before both particles cross, Q would also have to travel this distance from the maximum height. Okay, now look at something. When we calculated the maximum height raised by P from the ground, what did we get? What did we get? Yes?
80 meters.
Come again.
80 meters.
We got 80.
80.
Good. So if from here to here is 11.25, then what will be the distance from the ground to the point where they will cross? What will be the distance from the point, from the ground to the point where P and Q will cross? Yes. Yes, class.
8.75 meters.
So X will simply be equal to 80 minus 11.25, which will give you 60 what?
8.75.
0.35. Okay, and this is equal to the point where the two particles will cross each other. Class, does it make sense?
Yes.
Yes.
Another thought, which some of you also use, is that you see, from the ground to the maximum height, from the maximum height to the ground must be equal to 160. Must be equal to 160. So what has been the total, or what before P crosses Q, what will be the total distance P has or must travel? 80 plus 11.25. So when I sum 80 and 11.25 up and subtract it from 60, it would have to give you this as well. So 160 minus 80 plus 11.25 would also give you the same height. Class, does it make sense?
Yes.
Please, if you have any question, ask before we continue. Okay, now let's look out for the time of flight of P before crossing Q. The time of flight of P before reaching this point, before reaching the point where both particles would cross. Yes, what will be the total time for P? Please do it for me. What will be the total time? Or you think about the time taken for P to move from the maximum height to this point where it will cross Q. What is this time here?
1.5.
Good. So using V is equal to U plus GT, we can also calculate that. As at when P crosses Q, the velocity there is 15. Because P is free falling, U is 0. So 10 times T. So T therefore becomes 15 on 10, which is equal to 1.5 seconds. Plus, it means that it will take P, this